Adding and subtracting rational functions is all about the denominator. So if we look at example 1, r plus 6 over 3r minus 6. And I'm going to add it to r plus 1 over 3r minus 6. Like I said, it's all about the denominator. So since the denominators are equal, just like normal rational fractions, not functions but fractions, we can just add these two together. So essentially that would be like writing r plus 6 plus r plus 1, putting the two numerators together and dividing it by the one denominator. Because remember, if you have like 3 over 2 plus 1 over 2, you add it and you get 4 over 2. You don't add and get 4 over 4. So you keep your denominator the same. So then all we need to do is add like terms, and we have 2r plus 7 over 3r minus 6. There we go. We added those two rational functions together. The only thing we have to add in is our domain restriction. So r can't equal 2. Because if I plugged in 2 for r, then I would get 6 minus 6, which would give me 0. Alright, this is our second example. Again, we have like denominators, so all I need to do is subtract these two rational functions now. Now here's the catch though, because we have a subtraction problem, we need to put parentheses so that in our final answer, when we write it all out, we have m minus 3n minus m minus 3n. Okay, we have to distribute that negative like we just did. And then we have 6m to the third n. Alright, so after we subtract it, we have m minus m, which cancel out. And then we have 3n minus 3n. And this gives me minus 6n over 6m to the third n. So we're going to do like we did in class the other day, and we're going to simplify this. The 6's cancel out, so do the n's. So my final answer is negative 1 over m to the third. Now, we don't technically need to have a domain restriction for this because in our original we had two different variables. So these are the examples that I will allow no domain restriction to be. You don't need to include one. Okay, so now we have an example which have unlike denominators. So they're two completely different denominators. So what we need to do is we need to form an LCD between the denominators. An LCD stands for the lowest common denominator. So a lot of times this will happen, but our LCD is going to turn out to be our two denominators multiplied together. So 4x minus 1. Meaning, what can I multiply this first rational by and the second rational by? Maybe something different, most likely something different, but so that they both get the same denominator. So, knowing that that's my LCD, I know that this function over here is missing the 4. In the denominator, we only care about the denominator. So I have x minus 1 in the denominator, so to have my full LCD, I need to put in 4. So I'm going to multiply the numerator and denominator by 4 over 4. Now, in the 5x over 4, we need to look at that denominator. All we have is the 4. So we need to multiply x minus 1 on the numerator and the denominator. Now be careful when you do this. Again, since we have a binomial over here, put parentheses so that we distribute this properly. Okay? Alright, let's go ahead and do that. So I'm going to have 24 over 4x minus 1 minus, now I'm going to distribute that 5x. So I'm going to have 5x squared minus 5x. Now notice how I didn't distribute that negative yet. I'm going to do that now. And so now I have two denominators the same. The only thing left I have to do is I'm going to make this plus and this, the first one a negative and distribute it, and this one a positive. So now I can combine the two, and I can have negative 5x squared plus 5x plus 24. Now I'm writing it in standard form, all over 4 times x minus 1. The last thing you ask yourself is, okay, can I factor that numerator? So I had to put the numerator together so I can add it so it's one rational function. It's totally fine to leave your denominator in factored form because now you want to see, okay, can I simplify it even further? And unfortunately we cannot. This is as far as it goes. If you tried to factor the numerator, it wouldn't work. So the only thing left you have to add is your domain restriction. X can't be 1 based off of the original function. Let's try another one like this. 3 over x plus 7 plus 4 over x minus 8. The first thing we're going to do is we're going to identify our LCD. So, is there something that we can make the first rational and the second rational have together that creates this common denominator and the lowest one? Well, if you have two functions like this where you have them they're both in factored form, then our LCD just turns into x plus 7 times x minus 8. I'm running out of room. Alright, so what is the first one missing? Well, the first one is missing x minus 8. So I'm going to multiply by x minus 8 over x minus 8. And the second one's missing the x plus 7. X plus 7 over x plus 7. So now we really do need to just put our parentheses because we're going to distribute the 3 and then the 4. So I'm going to have 3 times x minus 8 over x minus 8, x plus 7, plus 4 times x plus 7 over x minus 8, x plus 7. I don't think I showed this step in the last example, so take a look at this one. All I did was rewrite it. I didn't distribute anything, and I didn't FOIL, I didn't multiply, I didn't do anything. I just rewrote it. Now this is the biggest mistake people make. They see this, and they want to go like this. Automatically they go, oh, well those cancel. We're done. Well, you can't do that, because if you do that, then you're left with this function we started with. So don't cancel it out until after we get rid of the addition sign by adding the numerators together. So I'm going to distribute that 3 and get 3x minus 24 plus 4x, now I'm distributing the 4, plus 28. All over x minus 8 and x plus 7. Again, keep it in factored form. It's going to make it so much easier. Alright, so you can continue with this one. And now, let's see, we have 7x plus 4 over x minus 8 times x plus 7. Again, you want to see if this can simplify, and since the numerator doesn't have an x minus 8 or a factor of x plus 7, it can't simplify any further, and so the last thing you need to add is your domain restrictions from the beginning, so x can't equal negative 7 or 8, and those domain restrictions actually stay true the whole time because we have our x minus 8 and our x plus 7 right there in our final answer. Okay, example number 5. The first thing that I see to do is to factor this 2x minus 2. So I'm going to go ahead and do that. I can pull out a 2, and then this 2 becomes a 1. So there we go. I factored it. You always need to do that first. So now we can identify our LCD. All right, so what does this fraction have that this one needs? Well, that has a 4, this one only has a 2. So that means I need there to be another 2. I'm sorry. Let's start over. All right, so our LCD, we have a 4 and a 2. So the lowest value that we can make out of those two coefficients is 4. Because this one is a 4, so we can't make it smaller, we can only make it bigger. But since we can make 2 into 4, then we can multiply the second one by 2 to get the 4. Alright, so we can have 4, and then our first function right here, our first rational fraction, needs that x minus 1. Sorry about that. Alright, so to have our 9 over 4 have an LCD of 4 over x minus 1, all we need to do is multiply this one by x minus 1 over x minus 1. Now over here, our second rational, it has a 2 and an x minus 1. So the x minus 1 is fine, so all we need to do is multiply this one by 2 over 2. Alright, so we're going to have 9x minus 1 minus 8 times 2, which is 16, all over 4x minus 1. I'm going to distribute the 9, and I'm going to get 9x minus 9 minus 16 over 4x minus 1. So we're going to continue to subtract that numerator and add those like terms. So I have 9x minus 25 over 4x minus 1. Nothing can simplify. I can't pull anything out of that numerator. So this is our final answer, and we're just going to say from the original, x cannot equal positive 1.